Well, fallacies are everywhere, and some of them are trickier to spot than others. One especially tricky and common fallacy is the fallacy of origins, sometimes called the genetic fallacy, which presents as a refutation of an argument the background that led to the conclusions that argument concludes. So suppose we're in the context of a debate about infrastructure, and I say, we should repair this road, and someone else responds, well, the only reason you think that is because you drive on that road every day and its state of disrepair is inconvenient to you. Well, that may well be true. But it says nothing about the claim, we should fix this road. That is to say, it doesn't tell us whether or not we actually should. It could well be that it is inconvenient for me, that's why I'm making the case, and also we ought to fix it. A lot of these arguments about oughts are very difficult, but arguments about is are more straightforward. And this video mostly focuses on those and how the genetic fallacy creeps into those contexts. The fallacy of origins works by attacking the source or origin of an argument rather than the argument itself. It's sometimes also called the genetic fallacy because it attacks the genesis of the idea rather than the idea. This fallacy is extremely common. Here's a basic version of it. Suppose I say, time is an endless loop. It just keeps looping back on itself over and over and over again. And you want to refute me and you say, well, you only think that because you came up with that idea after you had a dream in which you saw a snake eating its own tail. Well, that doesn't attack the actual claim. What it does attack is the way I came to the claim, perhaps, at least at the outset. This might seem like a bit of a silly example, but I've picked it specifically because of its applicability to the history of science. Carbon molecules are a ring, and the scientist who discovered this, Auguste Kekulé, came to the conclusion after having studied carbon for some time, had a dream in which he saw a snake eating its own tail, and said, oh, well, perhaps the carbon is a ring. The investigation subsequent to that turned out to prove him right. But I would never be able to say to him, you only think that because of a dream. I would be committing the fallacy of origins. I am attacking the origin of the idea rather than the idea itself. Versions of this argument are extremely common. And as is generally the case with fallacies, it's worth asking not only how they work, but why it is that they at least sometimes seem compelling. And you might think that refuting arguments in the sciences is really a sort of fallacy of origins, in the sense that we look at a methodology and we say, this methodology is flawed and therefore we don't believe your results. That is to say, the way that you came to the conclusion you came to is suspect and therefore we don't have to buy the actual conclusion. This is really a fallacy of origins, but in this case it makes sense because independent of our formation of an initial hypothesis, say that carbon is a ring, we also conduct experiments in accordance with the scientific method to test our hypothesis. And if those experiments themselves don't meet the appropriate standards, then it casts doubt on the hypothesis itself. So here again, we have a fallacy that in some versions looks kind of ridiculous, like you would never fall for it, but in many contexts seems to actually work just fine. The problem is that between the contexts in which it's appropriate and the contexts in which it's not appropriate, there's this hazy area, and that seems to be the place where it gets most used. In general, though, anytime we see an attack on the background of an idea rather than on the idea itself assessed on its own merits, we should be suspicious that something like a fallacy of origins is going on. And like so many fallacies, once you develop a sense for it, you'll see it everywhere.